Hi, good morning. This is John with Horizon Info Labs. Today, let's spend some time talking about Java JVM. I think we've all heard a lot about Java JVM. Let's quickly look into that a bit. Uh, so before we, go into details of Java JVM, let's just try to understand a little bit about how Java, talks with the operating system. So if you look there in this PPT, there is the Java there, and then you have different types of operating systems, right? Like Windows, Linux. You have your Android stuff. Uh, so essentially, how Java talks to these operating system is through uh, a translator, called JVM. So the code that is written in Java, doesn't Windows will not be able to understand it as it is. So it goes to a JVM, and then JVM translates it into something which the Windows operating system will then be able to understand. The same goes with other operating systems also. So there are like translators for different operating systems. So why would we need this? If we just look at this in a generic concept context, like let's say if Java was like some kind of an author who writes something in English, right? He writes a story or something, a novelist. Uh, so now, in case he wants, so people who read English would obviously, read his stories. But then, what if he wanted somebody sitting in China, somebody who spoke Chinese, to also read his stories? Somebody in Japan to be able to understand his stories? Somebody in Africa to be able to understand his stories? So he could achieve it in two ways. He could either learn that specific language and then write the story in that language, right? Or he could get get somebody from China or from Japan to convert his work into that particular language. So obviously, the later option would be the one that would be more suited, because uh, it wouldn't make sense for the writer to go ahead and learn the different languages and then write novels in that particular language. So the job that he does best is write novels in English, and then he leaves the other job to the translators. So the same concept applies here with the Java one. So it is this very concept which makes Java so universal. It's just that you can write code in a particular language and then just forget about it. It runs in all sorts of platforms, right? It runs in a Windows operating system, it runs in a Linux operating system. How is that achieved? It's achieved because of this JVM guy there. He's able to translate your Java code into that particular operating system. So let's just look a little more into this. Just move over to the next slide. So before when does it all start? When you compile a program, right? So if you've written a small program in Java, and when you compile it, exactly what happens there? So this story starts. This is before going to the JVM world. So we are just starting from step one. Step one is you write the program, and then you hit the compile. You hit the build button, right? So what happens then? So when you do that, there is a Java compiler. It's there with the JDK that we downloaded in the last lesson. What it does is, this Java compiler doesn't interact with the operating system at all. Okay. Um, So what this does is it takes this Java code and converts it into a byte code. So now this byte code is similar to the machine language, the code which the operating system understands. But then it is something that is going to go in as an input for the JVM. Okay, it is a food for the JVM. Okay, so when you write a program, right, what you will notice is that uh, uh, the code appears as a dot java file. Okay, and when you compile it, what happens is the byte code appears as a dot class file. Let's just quickly look at it. Let me just open Eclipse here. So in Eclipse, what I've done is I've created a couple of Java Java programs, right? So what happens is, once you create the Java, I've already created it. Let me just go in and create another one. New class, Java class, test2, test3, test3, test3. Let me just click finish it. So now what I've done is, I've created a .java file. I'm not going to put anything inside it. So now once I create it, let's just go into this location here. There is a bin location here. If you see, there is no class file here. The class file you see here are the ones that were created earlier. But then right now we created something called the test.java. Okay, so that is in the Java language, and a bytecode has not yet been created for it. Now when you go into your project and you just say build your project, what happens? You see here, you get the Java class. That is essentially a bytecode which the compiler has created, which corresponds to this Java test.java, right? So just to give an illustration of that, you could also if you go to the navigate into your desktop file location, wherever you have saved your project, if you just go down into your project location, you could see the Java and the class files there as well. So in my case, it is under this Java src comp location, and the class files will be under the bin location, bin comp location there. So now we have the class files, or what I was saying was the byte code. So we have not gone into the JVM yet. Okay, the JVM hasn't started doing its work yet. So now this byte code is ready to be fed to the JVM. Okay, so now what happens when you run a Java program? So it's not the build part. It's what happens when you do this, when you go in and click the run option, right? When you execute it. Essentially what happens is, JVM comes into play, and something called a class loader inside the JVM, it picks up your class, the file that you created with extension, and it loads it into memory. So this class loader basically loads the file into the memory, as simple as that. And once the file is loaded into the memory, something called a bytecode verifier checks the bytecode. So on a high level, it just goes through the bytecode to understand that the JVM will be able to process the code properly. It's just to make sure that that is a big topic in itself, which we can cover later. But then it basically goes through the code and makes sure that the code is ready to be processed. Okay, and inside the JVM there is the execution engine, which then converts the bytecode into a language which the OS understands, and then executes that language step by step. So all of these things are done by the JVM. Uh, so if you let's just go a bit more in depth into JVM, to kind of understand what it does there. So we've seen the class loader, it loads the class, and then there is a separate memory area within JVM where so it's a memory area and the JVM has different sections for different pieces of code. uh, Now we haven't really covered much about class, heap, stack, and stuff like that, but then quickly to go through what these memory does. So uh, when the program that I showed you earlier, let me just uh, open a program here. So this program is a class. So when we go into the OOPS concepts, we'll talk in detail about what a class is, but then uh, it's basically a blueprint of an object. Okay, and when a program runs, information related to the blueprint of the this object gets this class gets stored in these areas, the class area. And the heap area is something where a class is like a blueprint, and more objects are created out of the class. when you run the program, we'll see that. So those objects get stored in the heap area, and then there are several other areas, the stack, where it holds the variables and the partial results into the stack. Um, then there is an area called the native stack method stack, which contains all the native methods which are used in the application. And finally, there is the execution engine, which we talked about. It converts the bytecode into the machine language. So the execution engine basically it contains three things. It contains a virtual processor. It contains the interpreter that reads the bytecode stream and then executes the instruction, and it also contains something called the just-in-time compiler. So this is used to improve the performance of the JVM. So this JIT basically compiles part of the bytecode that have similar functionalities, same functionalities at the same time, so that the compiling happens faster. So uh, so that was high level about the architecture of the JVM. Now, so when we talk about JVM, we also come across something called JREs and JDK. So if you look at this picture, let me just make it a little more smaller, right? So when you we downloaded the folder that in the previous lesson we did download a JDK. Okay, so and if you look inside the JDK, you will have JRE inside it, and JRE implements a JVM. So a JDK and JRE are all physical files. So let me just go into my machine, the location where I have kept the file. So when we downloaded in the previous video, we've just gone down here into Java, and it kept the JDK here. So if you look at it, this folder was downloaded, and this JDK has got uh, some development tools. When you run the I think for compiling the Java and stuff, Java, if you go into the library, so we are at the JDK level, and if you go into the library, you can see all of those Java C, those kind of tools in here. Okay, for go into the bin. So if you which has which is used for compiling and stuff, so that comes in with the JDK. Okay, and so JRE is part of JDK. So we've gone inside, and what does JRE have? JRE has got certain library files which is used by the JVM to to initiate the JVM, to start up the JVM. So JVM is not a physical thing. The JRE is a physical thing. So JVM gets created by using the libraries inside the JVM. Okay, so basically all of JVM is like a subset of comes under a JDK will hold the JRE, and then the JRE will initiate the JVM. So there are different JDKs and JREs for different environments, which we saw at the start of the session, where there is a translator for Windows and Linux. So if you go to the Java site, you will see JDK for Windows, JDK for Linux, for different, you'll get different options there. So each of them will be different. Okay, so that was in a nutshell about our Java JVM. Thanks a lot for listening. Thank you.